And now for logarithms. So whenever you take the logarithm, think of it as an exponent. For example, if you take the ln, the natural logarithm of y, what you actually find is a number, for example, z, and this number z is actually the exponent that you have to raise the number e to in order to get your y number. For example, this would be equal to the ln of y, which is just y itself. Okay, so whenever you take the logarithm of something, you're actually finding an exponent. So with that out of the way, we can specify nonlinear models using the logarithm of either y or the x variables. So what you do in practice is to just transform or not transform, you just create ln, it should say, you just make a new variable, and ln of y, for example, and in this case you have y1, y2, y3, and in this cell you would just put the ln of y1, and here you would take the ln value of y2, and so on, and then you would use this new variable in your regression and not the y variable. Okay, so it's super easy to transform these or make new variables such that you get a logarithmic model. But observe that for a change, a d means change, or a small change in the logarithm of a variable, in this case x, then it's equal to the relative change in x divided by x itself, which gives you the percentage change in x for very small changes in x. The changes have to be on the scale of maximum 1 or 2%. Or you can think of it this way: if the change in x is fairly small, then the difference between the x plus the change minus the logarithm, the natural logarithm of x itself, is approximately equal to the percentage change. And how can we use this logarithmic transform of our variables? Well, we have three cases where the logarithmic transform might be useful. So, for example, if you hypothesize that a percentage increase in x is related to a unit increase in or unit change in y, then you use the linear log model. So a linear log model means that the x variable is transformed logarithmically. In this case, how you interpret the model is that a 1 unit or a 1% increase in x gives you a 0.01 times beta 1 unit unit increase in y. Okay, and you also have the log linear model, in which the y variable is transformed, and in this case a 1 unit increase in x is related to a 100 times beta 1 percentage increase in y. So in this case, if you hypothesize that a unit increase in x should involve or be related to a relative increase in y, then this is the model you should use. And lastly, you have the log-log model, in which both the y variable and the x variable has been logarithmically transformed, and here you get the percentage increase in x. A 1% increase in x gives you a beta 1 percentage increase in y. So this would give you the elasticity between y and x. And how can we compare the linear log model? The linear log model, remember that linear log model uses the y on the left side and the logarithmic transform of x on the right side, which means that you have y equals something. And the log-log model, well, there you have the logarithmic transform of y is modeled by the logarithmic transform of x, but we can't use the r squared or the adjusted r squared to compare these two models, because the dependent variables in these two models are different. So you can't compare the r squared models. In this case, you have to use economic theory to guide your decision in which model you would keep.